so today we're going to start talking about matrices. We're going to be doing this until we take our exam, so you don't need to bring your books or your student journal. I have a packet of notes we'll be going through, and then we'll be doing just worksheets. So looking at matrices, we're going to be talking about how do we add, subtract, and multiply these. First of all, you have to understand what a matrix is. It's just a rectangular array of numbers. It's a way of organizing information. So if we have a matrix, we call it an M by N matrix. And we say that it has M rows and N columns. You have to understand that a column, if you think of a column out in front of a building, which direction does it go, horizontal or vertical? Vertical. So right here in this problem, these would be called the columns. And then what I'm putting in the boxes, these would be called the rows. So again, it says that the dimensions of the matrix are going to be known as M by N, rows, columns. So how many rows do we have? 3. So this would be a 3 by 2 matrix. That would be the dimensions of it. What about on this one? What would be the dimensions of it? 2 by 5. See how we have 2 rows and then we have 5 columns. So this is a 2 by 5. So then it says, what are matrices used for? Well, like I said, it's to organize information. Perhaps this is talking about store A and store B, and their sales for Monday, Tuesday, Wednesday, Thursday, Friday. This would be a way that they could organize their information. It's kind of like a spreadsheet type of thing. So if we wanted to add matrices, which we're going to do down here later, what do you think would have to be true of the matrices in order to add them? They'd have to have the same dimensions. They'd have to be the same size. Otherwise, it wouldn't make sense. Like, you would have to have a store A, a store B, and a Monday, Tuesday, Wednesday, Thursday, Friday in order for it to make sense to add the two. Okay, so we're going to be looking at that later. I want you guys to figure out what the dimensions are of these two and write it down. Luke, what's the dimension of the first one?
3, 2.
Do you agree with that, Megan? What should it be? Yeah, remember that the rows, the number of rows we have, rows go across, we have 2 rows, and then the columns are the ones that go up and down by 3. So 2 by 3. All right. Linda, what would we call D?
4 by 1.
Okay, do you agree, Josh?
Yep.
Yep, that's right, 4 by 1. Okay, so down here it says to add and subtract matrices, the matrices must be the same dimensions. So we have matrix A, B, C, and D. These are both 2 by 2s. These are both 2 by 3 matrices. So it asks us to add matrix A plus B. Well, all we have to do is add the entries. So if I'm adding matrix A plus B, this is in the first row, first column, so I add the first row, first column positions. So 4 and -6 added together are -2. In this spot, I add these two numbers that are in that same position of being in the first row, second column, and those are -6. I add these two. 6 plus 7 is 13. And finally, I add these two, 3 plus 3, and that gives us 6. Now, I'd also like to show you how to do matrices on your calculator. So get out your calculator. Now, adding those two matrices was so easy that we wouldn't want to use the calculator for it. But I want to show you how the calculator can work with matrices. So make sure your calculator is on. Go to matrix. On my calculator, matrix is right here in blue. So to get to it, I have to do second x to the -1. Now I have to go over to edit because I want to edit the matrix. I want to input this matrix. I push enter. It's going to ask me for the dimensions. This matrix is a 2 by 2 matrix. Now I want to put in my numbers. Push enter after every number. Once you've finished putting in the matrix, you need to go back to the home screen because you want to get out of the matrix menu. So you do second mode to quit. Now we want to put in matrix B. So we're going to have to go back and we're going to do second x to the negative 1. And we're going to go over and edit. And I want to put in matrix B. So I'm going to go down to matrix B. What's the size of this matrix? 2 by 2. We put in each number, hitting enter after each one. Once I have the matrix put in, I want to go back to my home screen. So I second mode to quit. If anything's on your home screen, then clear it out. Oops. And now I want to add those two matrices. So I go back to matrix. This time I don't want to edit. I just want the name of matrix A. Plus, I go back to matrix. And I want the name of matrix B. And I push enter. And it tells me that that's what I get when I add those two matrices. Okay? Like I said, not necessary if we're adding those matrices. Much easier just to do it by hand. Now, in the next problem, though, since I've already put these in my calculator, I might as well use the calculator to subtract them. So I would have to do like 4 minus negative 6, negative 1 minus negative 5. But watch what I can do quickly, guys. Hit second enter, and it brings up the last thing you did, and now just change that plus to a minus, and we can quickly subtract the two matrices. Questions on how to put those in? We use edit when we want to put them in. We use the names when we want to actually do something with the matrices. All right, matrix B plus C. Should I start adding those two? Why not, Josh? Right. This is a 2 by 2. This is a 2 by 3. I can't add them. It wouldn't make sense to even do so. So this one I just put can't be done, CBD. D minus C. I'm going to go ahead and subtract those. I'm not going to use my calculator. I think I can do it quicker without. 9 minus 4, 5. Negative 8 minus negative 1, negative 7. 1 minus 7, negative 6. 0 minus 0. Negative 5 minus 3. 2 minus negative 2. Okay? That's quicker than putting it into the calculator. Let's go over to the next page. Scalar multiplication is very easy. You do exactly what you would think you should do. This is negative 5 times this entire matrix. So what do you think we do with each of those entries? Yeah, multiply them each by negative 5. Negative 10, 5, negative 15, negative 20. So up to now it's been pretty easy. Now we get to the more complicated part, multiplication. For multiplication, it seems like you would just multiply the numbers that are in the same spot. But that's not what you do. To multiply matrices, the columns of the first matrix, first of all, they have to match the rows of the second matrix. Columns from the first must match rows from the second. What are the dimensions of this matrix? 2 by 2. What are the dimensions of this matrix? 2 by 1. Do the number of columns, remember this is rows, columns, rows, columns. Does the number of columns from this row match the number of rows from this one? Yeah, so I can multiply them. Here's what I like to do, is now just get rid of those. These two numbers are going to tell me the size of my resulting matrix. So my resulting matrix should be a 2 by 1. 2 rows, 1 column. 2 rows, 1 column. Here's how we do this, and it's not very intuitive, so watch closely. This right here is in the first row, first column. So I use the numbers from my first row in my first column. I multiply 1 times 5 and I get 5. Plus, I multiply 2 times 6 and I get 12. This right here, this is in the second row, first column. So I have to multiply my second row times my first column. I have to match these up, so it's going to go 15 plus 24. So my answer is going to be 1739. That's what I get when I multiply those matrices. Any questions on that? Let me do another one, and I think it will be helpful. This matrix right here, what's the size of it? 2 by 3. What's the size of this one? So I check. These two are the same. They match. So I can get rid of those. That means I can multiply. My resulting matrix is going to be a 2 rows by 3 columns. So I'm going to have 2 rows, but 3 columns. So to figure out what goes here, I have to use the first row in the first column. So I have to use the first row and the first column. I have to keep moving. I move across my row and down my column. So it's 15 plus 1, that's 16, plus 10 is 26. On the ACTs, it will always have a question where you have most of these filled in, but then it might put an X here. And they want you to find out what that X is. Well, this is in the second row, third column. To quickly find this, I would want to use my second row from my first matrix and my third column from my second matrix. See how I knew that? Because this is in the second row, third column. So I used the second row, third column. Figure out what that's going to be. What is it, you guys? 1. Okay? So the point is here, like they might put A, B, C, D, E, and they might say find E, right? You don't want to waste your time finding A, B, C, and D if you only have to know what E is, okay? All right, you guys now try to find what goes here. This is in the first row, second column. See if you can figure that out. Kerrigan? Let's check. We have to use our first row, second column. We do 5 minus 2 plus 0. I agree. Okay, let's go down here. We're not going to go in order. I want you to have to think a little more. So this is second row, first column. Emma? 21, do we agree? Yep, that's right. All right, now you guys figure out what goes here. Kelsey?
I got 12, sorry.
12, do we agree? Yep, that's right. And lastly, find out what goes here. Adrika? 2, do we agree? Good. Now, that's pretty complicated to do, isn't it? This would be something that if I were taking a quiz and allowed to use my graphing calculator, I would just use my graphing calculator. If I had to find the whole thing. If I only had to find one spot, though, I would just find that one spot without the calculator, right? Because by the time you put that whole thing in, you could have already had it. So think logically on these. All right. What if I asked you to multiply these? What would you say? Why not? They don't match, do they? This is a 2 by 3. This is a 2 by 2. So in the order it's written, I can't multiply because these two numbers aren't the same. What if it had been the other way around and this had come first? Then could we have done it? Yeah, so we're kind of glad it's this way, right? So we don't have to do it. Can't be done. Okay, this one. Now, guys, remember, you could also put this into your calculator. If I asked you to find this whole entire thing, I would put it in my calculator. But I'm not going to ask you to do that. I'm just going to ask you to find certain spots. So this is more ACT-like. They might give you all these spots, and then they might say, this is X, this is Y, this is Z. Find X, Y, Z. See if you can do that. Not an easy. What do you think X is? 26, do we agree? Yes, X equals 26. What about Y? Who knows what Y is? What do you have, Alec? 90. Do we agree with 90? Good, that's correct. And what about Z? What do you have, Ben? 56, do we agree? Very good, that is correct. All right, guys, nice job. Everybody's okay with that. Remember, it's rows by columns. Everything is rows by columns. The way you name them, the way you multiply them. If you've ever seen RC COLA, like that's kind of a good way to remember. It goes rows, columns. Okay? All right. And if you wanted to multiply matrices, guys, it's the same way. Like I would just go back to my matrix that I have. I would get the name. I would do times. I'd go back to my matrix, get the name of B, and then just multiply them, and it would tell me what they are. Okay? Okay, so you can go ahead and work on your worksheet. All you have to do are the odds on the worksheet, not the whole thing.